Okay, so we wanted to talk about how you would use the AVNET project, maybe bring in your own main.c and develop applications for the AVNET Kickstart board. So I'm going to launch SoftConsole 4.0, and SoftConsole 4.0 is required with the Kickstart board because the Kickstart board has a Flash Pro 5 programmer. We have two different versions of SoftConsole, but when you're using the Flash Pro 5, you need SoftConsole 4.0. And when you launch SoftConsole, there's a workspace launcher that will come up, and you can browse out to where your project is located. So this is where the Kickstart project is, so I'm just going to say OK. But if I needed to change, I could just hit the Browse button. So we create a workspace, and then in the workspace we can have multiple projects if you want to. So SoftConsole is going to open, and here is my project that's in there. Now, what's in that project? Well, there's something called the SimSys. There are drivers for the peripherals in SmartFusion2, and then there's something called drivers config. All of this stuff comes out of Microsemi tools. Drivers config can be exported from Libre 11.7, and this has configuration information like the clock rates in your design. The peripheral drivers here can be created from a tool we have that's called the firmware catalog, or we also have a firmware view in Libre 11.7 where you can create drivers, and then the SimSys can also be exported from Libre in the design firmware tab or in the firmware catalog. And then this files here under the LSR shield, that's all AVNET specific things for the AVNET application for this board. So it's all put together in this project, but say you wanted to create a new main.c and bring it in. So I could import that, so I click the project here. I'm going to say File, Import, I'm going to say Expand General, and I'm going to say File System. Next. And I'm going to navigate out. We have a main.c on the desktop, so I'll scroll through here, and there's a main.c. So I'm going to bring in this main.c on the desktop, and I want it to go into my project. So there's my project. I want it to go into that project, and I'm going to say Finish, and it will ask me if I wanted to overwrite what's already there, and I'll say yes. So here is a new main.c. Now when I bring in the main.c, the first thing I'm going to have to do is I'm going to have to do a build. And when I do a build, it's going to create an executable that I can use with the debugger. When I want to go in and specify the build configuration, I can select the project name and say project build configurations set active. And by default, we have two different build configurations that come with the projects. One that is called debug and one that is called release. The build configurations are tied to some internal settings, project settings rather, in the tool, and they're also tied to what's called these linker scripts. Linker scripts are part of the SimSys that gets created from the firmware catalog, and these are files that are used by the linker to specify the execution areas. So we have a linker script that lets you run from the internal flash memory that we call the ENVM. We have a linker script that lets you run from the embedded SRAM called the ESRAM. And then we have a linker script that lets you run from an external DDR memory if the board has memory connected to the DDR controller in SmartFusion2. Now when I say run, I should actually say debug. You see, three of these have the name debug in the name. When you build with a debug linker script, you're going to go on and use a debugger to develop your code, and we'll download to the target board, and then we can set breakpoints and we can develop the code. There's two other linker scripts that we provide that have production in the name. Production SmartFusion2 execute in place, and production SmartFusion2 relocate to external RAM. When you use a production linker script, all you're going to do is build the project, and that will give you a hex file that you would then program into the flash memory. So the difference between the two, execute in place, you'll build a project and the executable would run directly out of the flash memory. Relocate to external RAM is a hex file that will be stored in the flash memory in SmartFusion2, but when we boot the device, that code that's in that portion of the flash memory will be copied to DDR memory connected to the DDR controller, and then we'll actually execute from that memory in the DDR memory. So the first thing I need to do is I need to build my project, and I can come over here and I can say build configurations, and I can choose which of the build configurations I want to use. So I'm going to start out with debug, and I'm going to just say build all, and I'm going to see a lot of messages go by in the console view as we run all the tools when we do the build, the linker, the assembler, and everything. Go to the problems view to see if you have any problems. See if you have any errors. Errors or warnings will be reported there. You can also go to the console view, and you can expand the console view so you can see all the messages that came up. Sometimes if you have errors, going to the console view is useful because you can get a little more information. But I didn't have any. So I've built my project, and when I built the project, you see there's a folder called debug now. The folder name matches the build configuration I used. And in here, there's a little executable right here, this little Kickstart demo _SC4ELF. This is the executable I'm going to be able to download to the code using the debugger. There's also a map file so you can see where everything got mapped in the memory space and so on. So I've done this. Now the next step is I need to create a debug launch configuration. So I'm going to select the project name, and I'm going to say run debug configurations. Be careful, there's also run configurations. There's some stuff in Eclipse because it's kind of a general third-party freeware kind of IDE, but we don't really use some of these, so I'm going to go to debug configurations. And you see where it says GDB open GDB debugging. You can double-click on that, or you can select it and click the new launch configuration button. And what you'll see is the name field, the project field, and the application field should all be pre-populated. And you see this little application field is that little ELF that I showed you. Now, one gotcha I've noticed, if you create a debug configuration but you don't select the project name first in the Project Explorer, sometimes this doesn't all get filled in by default. You can do it manually, but sometimes you'll see that. Also, if we do another build and we use a different configuration, you'll see this field doesn't get built, and I'll show you that in a minute. This doesn't get populated, and the reason for that is because now there's going to be more than one application. It's not sure which one you want to use. So I've done this. This is good. Now there's something critical on the next tab here, the debugger tab. Here where you see config options, there's some commands and some board scripts. The command is tied to the particular device that you're using. The Kickstart board has a SmartFusion2 010, so you see where it says device M2S 010. M2S is SmartFusion2. We have different family members, so you would have to make sure that the device matches the target board that you have. And then there's also a file setting here that is used to specify the type of memory you're debugging from. And there's the file that's there by default, the Microsemi Cortex M3.cfg, works for the flash memory or for the ESRAM. If you use the DDR memory, you need to use a different file. We provide the file, you just have to change the settings here. Okay. But everything looks good because I have the right device and I have the right board file. So now I could just say debug and it will launch the debugger. And you're going to see that some messages will show up in red font. We're going to download the code to the board. We're going to open a new perspective, the debug perspective. This was my C++ perspective where I developed the code. When you launch the debugger, you get a new perspective that opens, and it has a different collection of views, more geared towards debugging. You can create a memory monitor, you can see variable values, see breakpoints, you can see register contents for the Cortex M3. The other thing you'll notice is that when you launch the debugger, that it will download code and then it suspends at the very first executable line in the main.c. So this is normal. And then at this point you could single step, you could just hit the run button and run the code, and you can also hit the instruction stepping button. And if you do that, you'll see the disassembly view. So you can see the assembly code and you can see the C code, and then you can single step either in the C code or in the assembly code. And if you look in the disassembly view, it'll show you the C code, and then you'll see all the assembly code that was generated from it. So if I just want to run my code, I would just hit the button here, and it would run. Not sure, was I supposed to have a terminal open there or something?
No, this is perfect. The LEDs are lighting on the board.
Okay, so this program just drives some LEDs on the board. I could pause execution just by hitting the pause button, and I could look at variable values, or I could set some more breakpoints by clicking over in the margin, and I could see them here, and I could enable them or disable them. Look at the register values and so on. You could also create a memory monitor if you wanted to and put in some address. Like for example, if we put in 20000000, that's the ESRAM address, and that's out where our code was, out there somewhere, because we're running from the ESRAM. So you could put in memory addresses and look at the data, and you could run the code, and if you pause it, if any data changes, you'll see that code would show up in red font. I must be in the wrong area here. Same thing with the variables. You can look at the variable values, and then if you run the code and pause it again, if a variable changes, then you generally see that in red font. So here I can debug in the ESRAM. And when I'm finished, I would just terminate the debugger. You could right-click and say terminate, or terminate and remove, or you can just hit the terminate button here. But it's important to make sure you terminate the OCD debugger before you launch another debug session. And that is a little gotcha with SoftConsole. Actually, at least used to let you launch more than one debug session. So you want to make sure you only launch the debugger one time. So I just demonstrated how to use the debug build configuration and debug from the embedded SRAM. Now if I wanted to, I could go back to the C++ perspective, and I could change the build settings. So I'll change the build configuration to release. The release build configuration is going to use the envm linker script. So I'm going to build the project. So I can click the build all icon. When I build the project this time, it's going to build an executable that will run from the flash memory, and you'll see I have a folder here called release now. Release has another of these little Kickstart demo _SC4 elf. You saw one up here before under debug. So now we have two of them. This one runs from the ESRAM, this one runs from the flash. You can get more information on that if you scroll through this map file. You can see where the different parts of the code are built, and so you can sort of become familiar with that. Now if I want to debug from flash memory, I have to build a debug launch configuration that uses the release elf down here. So I'm going to say run debug configurations, and I'm going to create a new debug configuration here. Create a new one. Now this time you see the application wasn't populated, and that's because we now have two of those little elves, one under debug and one under release. So I just say search project, and if you look in this window, you'll see two of them, and one's in the debug folder, one's in the release folder. I want this one to be released, so I'll say OK, and I can say apply. I should look at the debugger again to make sure that I have the right settings in the config options. I picked them up from before, but it's always worth checking. So now I can say debug, and this time we're going to download code, but we're going to download code to the flash memory. And you see these little dots down there. We were actually programming the flash memory on the board. And then again, we're going to stop the first executable line of main.c, and we can run the code. When we debug from the flash memory, we have 6 hardware breakpoints that are part of the Cortex M3 architecture, so we can still set breakpoints, and we can develop the code. And then once we're finished, we could go off and do our production build, which I'll show you next. So I'm running the code now, and I see the LEDs are still blinking again like they did before. One difference between running from the ESRAM, which we did before, and running from the flash is if you actually terminated the debugger, unplugged the board and plugged it back in to power cycle it, or just hit the reset on the board, you'd see that the code would actually run because it's programmed into the flash memory. If we did that after we launched the debugger with the debug configuration and we put everything in the ESRAM, if we power cycle the board, we're going to lose the content of the ESRAM, so the code won't run. So you can sort of convince yourself you're really running out of flash memory. Okay, so we've now gone and programmed the flash memory using the debugger after we did a build with the release build configuration that used the debug linker script. So now I'm going to terminate my debugger, and I could go back and I could use one of the production linker scripts if I wanted to create a production hex file that I could put into flash memory. Now let me just show you what will happen right now. If you say, well, I already have a hex file, I'll just put this into flash. The way you do this is you would create your hex file, and then you would come in and you would say update ENVM memory content. And this will open a dialog box that will show your partitions in the flash that we refer to as clients. So here I have a data storage client, and this is where we're going to store our code. So if I navigate out to my project, I'm going to try to bring in so if I go to release and I say there's a hex file, I'll bring that in. I should get an error when I try to do this. This one looks like maybe it happened to work, but this is not the recommended flow to use the hex file that's created from the release configuration build. What we want to do one more build using the production linker script, using one of these linker scripts right here. And I'm going to use the execute in place linker script. So to do this, I have to create a new build configuration because I only had two. So I'm going to go to the project settings, say project properties, and I'm going to expand build here, choose settings, and you see where I have these configurations from the pull down debug and release. I could create a new one. So I can click manage configurations and I can create a new configuration. I'll call this production. And I'm going to base it on the release configuration. And I can even put in the description, this is my production flow. So I'm going to create a new configuration called production. It's based on the release build configuration, and I'm going to go in and make a few changes to that. I can set it as active too. So I'll set it active, say OK. I'm going to choose it from the pull down here. And what I want to change is I want to change the linker script. So if I look in the settings here, and I go under linker and I go to general, you see there's this path, the CMSys, startup, GCC, production, execute in place. Oh, that's what it worked. It had the execute in place linker script there. So normally what you see there is the debug and ENVM linker script. They actually didn't have that in there. They had the production linker script in there. But what I would do is I would go out to the workspace, I would go out to my project under the SimSys Startup GCC, and I would choose the production linker script. Say OK, and then apply, and I would go through and do a build the project using the production linker script. Just double check that production is active. So I'm going to build the project. Now this is going to give me a production folder, and it also gave me an error. Okay, so looks like the error that we have was caused because of a setting where I added the linker script and I actually copied over the same linker script. So let me show you that. If I open the project properties and go to the build settings, look under the cross-arm compiler general where the linker script was. When I copied over the release configuration to make production, it already had the linker script path, and then I put it in again. So I put it in, actually I have it twice. We'll just delete one of these, say apply, and then we'll try to do a clean and do a build. And this time no errors. And so when we did this build, we have a folder called production, and we have a hex file right here. And when we use the production linker script, we don't use the debugger. We would just go back to Libro, and we would say update NVM content. And we would open that tool, and we would navigate to that hex file. So we would see our data storage client. We would navigate to that hex file, and then once we've done that, we would just import that. So I'm going to go out and use the production hex file that came from the production build. Say OK. Say OK here. And then I can generate my bit stream. And then I could even export the bit stream to be used for a production manufacturing kind of flow. When I generate the bit stream right here, I can even specify what I want in that bit stream. So there's some options you can configure. And here you see you can select if you want the fabric or the NVM, which is the flash memory, or both. Now if I already have the fabric program and I only want to update the NVM, I would just uncheck this, just leave the NVM and say OK. Then I would generate that bit stream, and what I'll get is a bit stream to just program the flash memory, and then I could say run program action and will only program the flash memory. So you can separate programming the flash memory from programming the fabric, and if the fabric works but you're developing the code, then you can just go in and create the hex file for the code and then just program that.